A monkey of mass 40 kg climbs on a rope, which is shown in the given figure, which can withstand a maximum tension of 600 Newton. In which of the following cases will the rope break? In the first case, the monkey is climbing up with an acceleration of 6 meter per second square. So the maximum tension which the thread can bear, T maximum, is equal to 600 Newton. So if we start solving it for the individual case, so what I can do over here, I can do an important thing, that I can solve for the maximum possible acceleration. So we are here solving for maximum possible acceleration while traveling in the upward direction. So we are solving for maximum possible acceleration. So if we are solving for maximum possible acceleration, so I can say that the maximum tension is 600 Newton. So a tension of 600 Newton is acting in the upward direction, and the weight of the monkey is acting in the downward direction, that is equal to 400 Newton. So if we calculate the value of the maximum acceleration which the monkey can attain, so we can write that F net is equal to ma. So if we are writing this equation, we write it as 600 minus 400 is equal to 40 into acceleration attained. So here we write it as 200 is equal to 40a. So acceleration in the upward direction which is possible is 5 meter per second square. So 5 meter per second square is the maximum value of acceleration which it can attain while climbing up. So in the first case, which is when it is climbing up with an acceleration of 6 meter per second square, the rope will break. So we are writing over here, the rope will break. In the second case, the question is asking us about while the monkey is climbing down with a certain value of acceleration. So as the monkey is climbing down with a certain value of acceleration, so if we solve for this case, that is 4 meter per second square while climbing down. So I am writing over here, while moving down So if we write the expression while the monkey is moving in the downward direction, so we write it as that the weight in the downward direction, that is equal to 400, the tension is in the upward direction which is equal to ma. So the acceleration is 4, so we can write it as 40 into 4. So again we are writing the equation F net equal to ma. Since the motion is in the downward direction, so we are writing the force in the downward direction minus the tensional force is equal to ma. From here we obtain that the tensional force is 400 minus 160, that is equal to 240 Newton. So for this case we are saying that the rope will not break. So in case B, we say that rope will not break. Rope will not break. Now in this third case, when it is climbing up with a uniform speed, so if it is climbing up with a uniform speed, then the net force is going to be 0. So while climbing with a uniform speed, I can take another page. So while climbing with uniform speed, we can say that acceleration is 0 and hence F net is equal to 0. So tension in the thread minus mg is equal to 0. So we can say that tensional force is just balancing the weight of the monkey, which is equal to 400 Newton. And again we can say that in this case rope will not break. So rope will not break in the third case as well. Now in the next case, falls down the rope freely under gravity. Now in this case, when the monkey falls freely under gravity, its acceleration will be equal to A equal to G. So if A is equal to G, so in the last case we are saying when falling freely under gravity, when falling freely under gravity, so we can consider it this way, that the acceleration is equal to G in the downward direction, So we can write that mg minus t is equal to mg. So over here we get t is equal to 0. So there is no tension acting in the rope, and hence we say that the rope is not going to break. So over here I can say again that in the last case also rope will not break. So this is how we solve when a single monkey is involved in a problem